All right. Good, good morning, I guess, mathematicians. I am sorry, but I got hit with a cold/flu this weekend and not doing so well. So please bear with me. I know it's late. But the learning must continue, right? So in today's video, we're going to be talking about cube roots. I know we didn't finish lesson 2.3 with the square roots. We will finish that when I get back, okay? So don't worry too much about that right now, but for right now, we're going to dive right into lesson 2.4. Okay, so first of all, copy down this focus question. What does it mean to take the cube root of a number? So take a few moments, write it down. Well, let's talk about what exactly is a cube root, and you'll notice that the definition here is pretty similar to our definition for a square root, right? It's a number multiplied by itself. 3, except you can't read that. That's supposed to say come on, work with me, please. Three times to get the number under the cube root sign. Now, notice that the cube root sign is written like this. It has a 3 and then a square root sign. That is very important, okay? So please, whenever you're writing cube roots, please make sure that they have that little floating 3, okay? If you take a look at this example, we're taking the cube root of 8, right? Well, you got to think of a number that you can multiply 3 times by itself, or by itself 3 times, to get the number we want. So I notice that 8, I can multiply 2 times 2 times 2. And because there are those 3 2's, well, that tells me that the cube root of 8 is 2. Okay? So the first thing that we're going to have you guys do here is to fill in this table of perfect squares and perfect cubes. Okay? The middle column here will be your squares, right? So all of the x values to the second power. And then your last column will be all of your x values to the third power. And my suggestion to you guys is get really comfortable with these values, okay? I'm going to have you guys memorize all of these because they will become so useful to you in the future, right? If you can recall all of your perfect squares and your perfect cubes, then you'll notice that some things as you progress into more advanced math become a little easier, okay? So go ahead, copy down this table, press pause, copy down this table, please, and then get to work on memorizing that, all right? Okay, but let's keep going. So, as I was saying earlier, we like to use a lot of shapes in math, especially geometry. Geometry is all about shapes and the relationships that are found within those shapes, okay? So with the square root lesson, we talked about how square roots or actually the square roots and x squared are related to a two-dimensional square. Today, we're talking about cube roots, and we're going to see how the cube root is actually related to a three-dimensional cube. So if you read here, it says the volume of a cube is the length of an edge multiplied by itself 3 times. Hey, doesn't that sound familiar? Hopefully it does. Excuse me. Multiplying 2 edges of the base. Now remember, edges are kind of like our side lengths. They're found along the edges of the cube. Multiplying 2 edges of the base gives the area of the base. The area of the base times an edge that is the height gives the volume. And the volume can be expressed by the formula V equals edge times edge times edge, or V equals edge cubed. So this cube has the volume of 8 cubic units. The length of each edge is the cube root of 8 units, which is equal to 2 units. So let's write this in more of like algebraic terms here. So they tell us, and please excuse my writing here, my Apple Pencil is dead, so I'm using a different stylus. So bear with me. All right, so they tell us that the volume is equal to, oh my goodness, 8 cubic units. And then the edge, I'll say E, is equal to the cube root of 8, which is therefore equal to 2 units. Oh my goodness. Okay. Hopefully my pencil charges quickly. All right. So question A1 says to find the edge lengths of cubes with volumes of 1, 27, 64, and 125 cubic units. So we need to think about, well, remember the edge lengths, you need to multiply it 3 times in order to get the value that we want, or the volume here. So take a minute, think about it on your own, and then resume the video. All right, so if your cube has a volume of 1, your edge length is also going to be 1 unit. Volume of 27, edge length is 3. Volume of 64, edge length is 4 cubic units, 4 units. And then a volume of 125 cubic units, well, your edge length is going to be 5. Now you'll probably notice that the math that occurred behind this, or behind this thinking here, is exactly what's presented in problem 2. Find the values of the cube root of 1, the cube root of 27, the cube root of 64, and the cube root of 125. So we actually end up with the same values here, 1, 3, 4, and 5. So that's the math that's happening when you are trying to go from, when you start with a volume, right, and you're trying to find the edge length, you take the cube root of the volume to find the edge length. I think that's worth writing down. If you're given the volume, so let's write it like this. If you take the cube root of the volume, that gives you the edge length, okay? All right, let's keep going. Now, what is the volume of a cube with an edge length of 5 units? Now, remember, what we just wrote was we took the cube root of the volume to get the edge length. But now we want to work the other way. What is the volume of a cube with an edge length of 5 units? So if our edge length is 5, we're going to cube it to get the volume. And 5 times 5 times 5 gives me 125 cubic units. What is the volume of a cube with an edge length of 2.5 units? So you're going to do something very similar here. You're going to cube the edge length. Sorry, I had to go run and get my calculator here. And so our volume is 15 and 625 thousandths cubic units. Oh my goodness. My writing is horrible on this. All right. So we need to think about the relationship between a cube root and x cubed. It is very, very similar to the relationship between the square root and x squared. And that relationship, hopefully you guys remember, is that they are inverse operations of each other. Okay, so we're going to take a look. We need to find the missing numbers here. So I'm going to rewrite this problem as the cube root of x is equal to 5. Now to solve for x, or to get x by itself, what you're going to do is you're going to cube both sides. You're going to cube both sides of the equation, and this cube and the cube root are going to cancel each other out, so all you're left with is x. And then, well, what is 5 to the third power? We already know is 125. And there you get your answer. Same thing with the next one. For question B, we're going to rewrite the problem as an equation. So the cube root of x is equal to 2.5. Whoops. And you're going to do the same thing. You're going to use inverse operations to isolate the variable here. So these are going to cancel out. We have x is equal to 15.625. Okay. All right. Now I want you guys to attempt these next 6 problems here. Okay. Use inverse operations to help you solve. Okay. And honestly, that's all I have to say. So try your best. Pause the video, try the 6 problems, and then we'll walk through them together afterwards. All right, hopefully you guys pause the video. Here we go. So first problem is x cubed is equal to 27. To solve for x, we're going to use the inverse operation, and we're going to take the cube root of both sides. The cube root is going to cancel out the cube, so we're left with x, and the cube root of 27 is 3. All right, let's keep going. I have the cube root of I have x cubed is equal to negative 27. And you might be thinking, well, Mr. RG, can I take the cube root of something? Well, let's take a look. If I take the cube root of both sides, right, these are going to cancel out. I'm left with x. Now, remember, the definition of a cube root, right, is a number multiplied by itself 3 times. Okay, I'm going to move to the bottom of the page. I'm going to rewrite. So this is the cube root of negative 27. I can rewrite this multiple ways. Well, not multiple ways, but I can rewrite this as the cube root of negative 3. Negative 3 times another negative 3 times another negative 3. Right? I'm multiplying this negative 3 by itself 3 times. So the cube root of negative 27 is going to be negative 3. And yes, you can have a negative value for a cube root. Okay. All right, let's keep going. Here we go. We have x cubed is equal to 1/8. Okay, and hopefully you guys are seeing a pattern here. We're going to take the cube root of both sides. So these cancel out, so I'm left with x. Now, what's nice about fractions is that you can rewrite things like this. So I'm taking the cube root of 1 over the cube root of 8. And we can definitely solve both of those. The cube root of 1 is 1, and the cube root of 8 is 2. So our answer is 1/2. All right, let's keep going. Question D is asking for the cube root of x is equal to 27. To solve this, I'm using my inverse operations. I'm going to cube both sides of the equation here. I'm going to get out my calculator. 27 times 27 times another 27 gives me, so x is equal to 19,683. There we go. All right, next problem. Question E says, the cube root of x is equal to negative 27. So again, I'm going to take my inverse operation of both sides. I'm going to cube both sides of the equation here. So I'm left with x on the left side and then negative 27 cubed. would be negative 19,683. All right, last problem. Here we go. This is the cube root of x is equal to negative 1/8. Now nothing's changing. We're still taking, let me change colors here, we're still taking the inverse operation of both sides, so we're going to cube both sides. So we're left with x on the left side. Now think about, what is negative 1/8 times negative 1/8 times negative 1/8? Well, negative times a negative is a positive, and then a positive times another negative. We're left with a negative number. And we have a 1 in the numerator, and then we have 512 in the denominator. So our answer is x equals negative 1/512. There we go. Okay, next, question 4, it says explain what each positive value of x might represent in terms of volume and length. Okay, so we need to take a look at, here I'll highlight here, we need to take a look at x equals 125, x equals 15.625, x equals 3, x equals 1/2, x equals 19,000, and that's it. So we have two options here. So when we solve the equation, when we solve for x, does x give me the volume of the cube, or does it give me the edge length of the cube? Okay. Well, when x equals 125, so I'm going to label this 2a. So for problem 2a, when we found x, well, what did we do? We cubed both sides of the equation. So it looks like when we cube something, we actually get the volume of the cube. For 2b, it was the same, right? We cubed both sides, therefore that's the volume of the cube. For 3a, we took the cube root to solve. So taking the cube root of the volume gives us the edge length. I'm just going to say edge. For 3c, we took the cube root, so that must be the edge length. For 3d, for the last problem, we cubed both sides. So that must mean that x represents the volume here. Awesome. All right, let's keep going, you guys. Okay. So here's what we're going to do. This is between which two consecutive whole numbers does the cube root of 10 lie? And explain. Okay. Before I explain this, I want you to try and answer this on your own. Okay. As a hint, I would use your perfect cubes chart. Okay. All right. So pause the video. Try it on your own. All right. Here we go. So like I said, it might be a good idea to refer back to this perfect cubes chart. Okay, we are looking for the cube root of 10. Okay, now the cube root of 10, well, I need to find the number consecutive. Remember, consecutive means the number that follows right before, and the one that follows right after. So let's take a look. I need to think of these as I'm going to be taking the cube root of each of these numbers here in this column. So in my opinion, it looks like the cube root of 10 is directly after the cube root of 8 and directly before the cube root of 27. So I'm going to write those down. So kind of like what we were doing when we were estimating square roots. So we're looking for exactly the cube root of 10. Right after it is the cube root of 27. and then right before it is the cube root of 8. We know that the cube root of 8 is 2. We know that the cube root of 27 is 3. Okay, so there we go, right? We just found the whole numbers directly before and directly after the cube root of 10. So we found those perfect cubes. Now it says which whole number from part 1 is closer to the cube root of 10. And explain. And this is before we do any work on the calculator. So if I were to take a guess, right, I'm looking at the numbers that are underneath the cube root signs, and 10 is definitely a lot closer to 8 than it is to 27. So if I were to make an educated guess here, I would say the cube root of 10 is closer to the cube root of 8. That says because, again, sorry for this stylus that I'm using, because the cube root of 27 is pretty far away, right? It's not, at least it appears that way. All right, so it says without using your calculator, we're going to estimate the value of the cube root of 10 to 1 decimal place. Now, we're going to use our calculator for the second part of this. So take a wild guess, and well, not a wild guess, but an educated guess. An educated guess as to where or what decimal or what approximation we have for the cube root of 10. So take your best guess. We're going to test a few points. I'm going to guess, I'm going to say 2.3. I'm going to see if, I'm going to type this into my calculator. I'm going to do 2.3 times 2.3 times 2.3. And this is equal to 12.167. So that might be a little too big. So why don't we try 2.2? And again, cube that, and we get 10.648. This is definitely a lot closer to 10 than 12.167. But for just to be safe, let's test 2.1 as well. That's 9.261. So if we're going for which is the closest, we'd probably say 2.2. Right? But we have one more question on this page, and it says, without using your calculator, can you get an even closer estimate than in part 3? And I'm sure that a lot of you guys are thinking, well, couldn't we go into the hundredths place or the thousandths place? And yes, I would say definitely yes. Definitely yes here. Let's try the hundredths place. So we'll start off by answering this question. Can you get an even closer estimate? And say, yes, let's expand the decimal. Okay, so you'll notice that 2.2 is actually over 10. So we probably need to start at 2.1 and expand the decimal going that way. So let's try 2.116. Let's try 2.16 and cube that. So 2.16 times 2.16 times another 2.16, and this is approximately 10.078. Pretty close. 2.15. Let's try that. Again, I apologize for the stylus. Oh my goodness. Times 2.15 times 2.15. And that is awfully close. 2.15. So you guys see, as we add more decimals, we can get closer and closer and closer to the exact answer. Okay? All right. So I'm going to end the video there because I believe you guys now have the knowledge to finish this on your own. Okay? So I want you to answer question D here. Okay? Discuss it with your group members if you guys get stuck. Okay? And please don't forget to explain. Okay? Especially when you guys go from actual numerical values to algebraic variable values, okay? Please make sure to explain, right? Now, the last thing that you guys are going to do is you're going to answer this summary, okay? Answer it, answer all 4 parts, and then once you answer all 4 parts, you're going to post to my Connect. Do not forget this. I'm putting this in my video because, believe it or not, some of you guys have forgotten to do this, okay? It will be an assignment on the MyConnect calendar. So please, 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 when you finish this lesson, post a picture of this part of your workbook, okay? All right, you guys. Well, again, I apologize for not being there today, but I know you guys can do it. I believe in you all. Please let me know if you have any questions, and I will see you in the next lesson.